The suspension system of a Formula One car forms the critical interface between the performance-generating components of power unit, chassis, aerodynamics, and tyres. It comes as no surprise, therefore, that the design, manufacture and set up of suspension is an extremely complex affair. We manufacture all of our suspension in-house. This is because they're very complex, and also they're what we call safety critical items. They're structural items, and the safety of the car and the driver depend on them. We make them in-house because we can control the quality, we're using expensive materials, and we need precision. The biggest challenges in designing Formula One suspension are to make the trade-offs between the strength, the weight, and the physical size of the suspension. And I say the size because these components are in the airstream. They have a huge effect on the car aerodynamics, so we need to minimize that effect. But at the same time, they are structural, safety critical devices, and we have to achieve the strength. And then we have to minimize the weight. So this means altogether, this is one of our big structural challenges and big manufacturing challenges that we have in Formula One. Now we can look at the three main parts of a Formula One suspension system. We have the inboard suspension, hidden away underneath the bodywork, where we have the springs and the dampers and the anti-roll bar. And here, hidden away under the tyre, we have the outboard suspension, which is the upright, the wheel bearings and the axle. And in between, the parts that you can see, which are the wishbone elements and the steering rod, which are the only items that really see the external airflow. In designing all three of these, common theme is stiffness. We have to have the wheel position controlled as accurately as possible. Outboard, we're looking at the challenges of high temperatures, they're close to the brakes. Inboard, we have the complex components, the hydraulic system, the dampers, the springs, the anti-roll bars. And in the middle, in the leg elements, we have the structural and aerodynamic challenge. You'll hear a lot in Formula One, drivers and engineers talking about balance. The reason is that these four tyres behave differently every part of the track, every corner of the track. And what we want to do is to control the relative amount of grip of those four tyres as the driver goes through the different phases of the corner and the circuit. What the suspension allows us to do is to change minutely the amount of grip that those four tyres generate at any one point on the track. And the way we do that is by adjusting the inboard settings of the suspension, by adjusting the damping and adjusting what we call the mechanical balance. That's because with that adjustment, we control the change of grip from the rear axle to the front axle. And that depends on the car speed and the track conditions. When we're running the car on the track, we make sure that we look at the suspension loads that we're generating. Sometimes we take that from sensors on the internal suspension, and sometimes we take that from sensors built into the suspension itself. And it's very critical for us to understand the real loads the suspension sees. So the maximum loads that we're designing the suspension for are based on simulation and are based on previous year's experience, and also a collection of unusual loads that we've recorded over the years in unusual conditions. Spinning the car, going backwards over a curve, hitting the brakes while the car's in the air and landing. And these are all critical additional load cases that have to be dealt with in the suspension design and testing. The suspension systems on a road car provide two functions. We call those ride and handling. And ride is about dealing with the surface of the road, undulations, bumps, curbs, changes in camber, ensuring that the grip is spread correctly between the four tyres. The handling is about dealing with the dynamics of the car, how the car behaves under braking, how it changes direction, how it does what the driver wants to do. Now, a Formula One car has got the same demands of ride and handling, dealing with lumps and bumps, curbs in the track, dealing with more aggressive dynamics of corner entry, braking, steering, acceleration. But the Formula One suspension has a third function, which we'll call platform control. Because Formula One cars generate enormous vertical forces from their aerodynamics, the suspension has to deal with literally tons of extra load on the car at high speed. And we have to make sure that the position of the car relative to the road is well controlled, because this has a very important effect on the aerodynamic performance of the car. Road cars and Formula One cars, very similar. They both have ride and both have handling control. The difference is with the Formula One car that it needs the platform control as well because of its dominant aerodynamic effects. We've been working with Daimler, in particular their ride and handling group, for many years, developing our tools for developing suspension systems. In the early days, we had Daimler engineers working directly with us, and as we've evolved our relationship, we've been developing the models, the tools that allow us to design. And the interesting thing is that although these components look very different, the fundamental physics is very similar. And we've been able to share lots of techniques in designing and analysing these complex systems, particularly the complex hydraulic components of the suspension. And some of these components on the road cars now share very much the same design philosophy as the Formula One components. So the suspension is just one of the many systems that link the Formula One car to the road car and show the bidirectional link between Daimler and Mercedes-Benz Formula One.